All right, number 6. Okay, we have 13 factorial divided by 11 factorial, 2 factorial. Right, so the rule that I want you guys to follow is you find the biggest number on the bottom. That's the one you're going to divide out. So with this 13 factorial, we're going to start spelling it out, and we're going to stop when we get to 11. So 13 factorial is 13 times 12 times 11, and I'm going to write 11 factorial, and I'm going to stop there. Because 11 factorial just goes all the way down to 1, and instead of writing that out, since we have 11 factorial on the bottom, those two will divide each other out. But the 2 factorial, we will continue with that one, which is 2 times 1. Okay, 2 times 1 is 2, and 12 is divisible by 2. So divide by 2, and that leaves you with 6. And so all we have to do is multiply 13 times 6, and 6 times 3 is 18, carry your 1, so 78. Also, just to show you, if you have that calculator again, I'm going to go through that a couple times. So if you have this graphing calculator, let everything back up. If you have this graphing calculator, you can put all of it in just like this, okay? So what you would do, put the top in parentheses and the bottom. So I would open parentheses and do 13, and then the math button, you're going to arrow back to probability, and then option number 4. So it has 13 factorial, and you close parentheses, divide it by, and then open parentheses and put the whole bottom in parentheses. So 11 math probability factorial number 4. So we got 11, and then it's going to do 2 math probability option 4. So this is what we were given. If you hit enter, you get that, and the same thing if you just do 13 times 6 when you reduced it all by hand. All right, so 78 multiple ways. Now, number 7 says a panel containing 4 on-off switches in a row is to be set. Assuming no restrictions on individual switches, use the fundamental counting principle to find the total number of possible panel settings. So we have 4 on-off switches to be set in a row. No restrictions. Use the fundamental counting principle to find the number of possible panels. So the fundamental counting principle just says you're going to multiply. If you have an experiment or a setting with multiple layers or multiple choices, in this case we have 4 on-off switches. Okay, you're just going to multiply each of those together. So we have 4 on-off switches, but there's 2 positions that they could be in, on or off. So each of those switches has a choice that comes with 2 options. Okay, so the fundamental counting principle just says you're going to take each of those stages, whatever a multi-stage experiment, and however many outcomes or options you have, you're going to multiply that number times each stage or each individual one that you have. So 2 times 2 times 2 times 2. 2 to the 4th, we get 16. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So there's 16 possible positions for putting these switches in on and off settings.